Assalamualaikum warahmatullahi wabarakatuh. My name is Zaida Zamri. My metric number is AF220146. In this video, I'll talk about the fixed beam. This fixed beam is located in room G4D016, College Kediaman Tun Dr. Ismail, University Tun Hussein Al Malaysia. The beam is made of concrete and the function is to support the weight of ceiling of the building and to transfer the load to a vertical load bearing structure. A brief introduction of the beam. A beam is a structural component that resists loads mostly applied laterally to its axis. Fixed or encasted beam is a beam supported on both its ends and restrained from rotation. Reaction forces are produced at the beam support points as a result of the loads applied to it. This is the free body diagram of the beam. Estimation of loading or action on the beam. Assume that the load is 35 kN per meter. Length of the beam is 2 meter. Thus, the uniformly distributed load on the beam is the 70 kN. Moving on to superiority of the beam. Because this is a fixed beam, so there are rotation at both ends of the beam. Taking rotation at point A, so we get the upward force at the point B is equal to 35 kN. Next, sum of forces in y directions is equal to upward force at point A plus upward force at point B minus the 70 kN load. So we get upward force at point A is equal to 35 kN too. Sum of forces in x direction is equal to the horizontal force at point A minus horizontal force at point B, that is equal to 0. So they cancel out each other. Thus we get horizontal force at point A is equal to the horizontal force at point B. Next is centroid of the beam. After calculating the area x, y, ax, and ay, I get x bar as 1 meter and y bar is 0.25 meter. Lastly, moment of inertia of the beam. After the calculations, we get moment of inertia about x-axis is equal to 0.02083 meter to the power of 4, and the inertia at about y-axis is equal to 0.3333 meter to the power of 4. That's all for me. Thank you.
My name is Glima Anapita AF22003A, Static Dynamics Section 1, Dr. Norley. Today I'm going to give you this justification and why I choose roof structure as a continuous assessment for static project in my teammates video. So this photo were taken in front of College Pugura. As you can see, this warung selling a very decent and exquisite meals for residential home and utilization student that's staying in College Pugura. There are main 3 key points in introduction: part of building the envelope in covering uppermost of building homes, the outer layer of roof depending on availability of material and the nature of the support structure, and last but not least, the process of building and maintaining the roof is called as roofing. So in this diagram, support ratio of the roof truss on horizontal axis is there is no forces that acting on x-axis. We can assume that Fx equal to 0. When moment at equilibrium, force time distance, we can deduce the By reaction is 2 kN and Fy at equilibrium on the vertical is 12.4 kN in approximation for the forces. For next is calculation of centroid. As you can see, center of gravity and center of the roof trusses divided 2 different sections, section 1 and section 2, 20 meter length with 26 height in meter, both in meter, and for the triangle formula is 1/2 times base times height. So 1/2 times 10 times 26 is 130. Then the summation between section 1 and section 2 is 260. So the AX value is 130 times 3.33. We're getting 432.9. 130 times 13.33 for section 2 is 1732.9, and AX value divided by area is 8.33. Meanwhile, for AY value is 130 times 8.67. Both are getting for section 1 and section 2 is 1127.1, and AY divided by area is 4.335. Besides that, for the moment of inertia, there are 2 different sections which is part section X and part section Y. So I'm going to use this table to really differentiate both sections. So the meters in area in meter square, Ix referring for inertia, dy changes in Y. We know a dy square is the inertia times with the changes in Y. Meanwhile, for the part section Y also having inertia of X, dx also changes of X, and a dx square for the inertia in changes in X. For the section 1, we can deduce that the inertia is 4882.22 and also getting the same value for the section 2, 4882.22, but both also have the same changes of inertia, which means they have increase in 44.2. For the part section Y, we can see also exhibit inertia at the same value 722.22, and ADXY is 3250. And last but not least, calculation of the inertia at X, at part X, is 9852.84 in meter fourth, and meanwhile inertia in Y part is 6774.42. And last but not least, in the summary, in this particular study is the structure of building in this warung. By seeing the calculation for the pre-body diagram, support reaction and centra, and the moment of inertia, we can conclude that the structure of truss event that allows the weight of the roof to be distributed to other walls or column for better support. The engineering principle behind the truss and the shape of triangle or series of triangle in geometry. A triangle is very strong, and a structure a truss is a structure that comprising one or more triangle units constructed with straight members whose ends are connected at joints referred as to nodes. And thank you for listening.
Assalamualaikum and salam sejahtera. My name is Farzana and I will explain about cantilever slab. For actual structure, I choose SA apartment and Camera Highland. The material is concrete. Function for cantilever slab is common features in residential and commercial building due to the need to have bigger space on upper floor. For axial force at point A, FAX is 0 and RAS is also 0. Shear force at point A, FAY is 0, RAY is 180 kN because we need to convert from UDL to point load, and the load located at the middle of 4 meter, which is 2 meter. For moment at point A is 180 times with 2 and we get 360. For centroid, first we need to calculate the area for column 1 and for x-axis divided by 2, and also for y-axis, then A times with x and A times with y. For column 2, we repeat the process, but for x-axis we need to plus with 0.7 and y-axis we need to plus with 2. Last, we need to total of area A times with x and A times with y. For centroid at x-axis of the cantilever slab is total of AX divided with total of A, and we get 1.29. For centroid at y-axis is total of AY divided with total of A, and we get 2.74. For moment of inertia axis X is we need to have an area and calculate the inertia X for column 1 and column 2 by using formula B times with H power of 3 divided with 12. For D, we need to calculate the differentiate point of centroid of the column 1 and the centroid of cantilever, and repeat for column 2. And at last, calculate A times with D power of 2. So the total moment of inertia about x-axis is 13.40. For moment of inertia axis Y is we need to have an area and calculate the inertia Y for column 1 and 2 by using the formula B power of 3 times H divided with 12. For S, we need to calculate the differentiate point of centroid of the column 1 and the centroid of cantilever, and repeat for column 2. And at last, calculate A times with S power of 2. So the total moment of inertia about y-axis is 30.80.
My name is Nur Aina Zulaika binti Zamzuri, metric number AF220005. I will be presenting regarding short span bridge for my group. So here we have the structure that I chose for this project. I chose this structure because it is a very pretty looking bridge, and the location of this short span bridge is at Audrain County, USA. The material used to build this bridge is concrete, and the function of this small bridge is to connect from one side to another for crossings over small rivers, road intersections and others. So the length of this bridge is 15 meters, while the thickness is 0.61 meters. So as you can see, I interpreted this structure to a free body diagram. The free body diagram that I chose to draw is like this. The length of the bridge is 15 meters, while the thickness is 0.61 meters, and the dead load mass is 3,000 kgs. And what I have known, this bridge uses two kind of supports, which is at point A it is used as a pin, and at point B it is used as roller. So the next part is support reaction. So given the slack weight is 11000 kgs, and it is interpreted as support reaction on the structure like so. I have drawn HA on the x-axis, VA and VB on the y-axis. So the calculation is like this. So the mass of dead load is 3000 kgs. So the weight is 29.430 kN, and the mass of the beam is 11000 kg, and the weight is 107.910 kN. So the total loading act on the beam is 549.36 kN. So the weight of the loading act on the beam is 36.624 kN over meter. So the calculations will be total MB is 0, so it will become negative VA times 15, because it is 15 meters in length, plus 36.624 times 15 times 15 over 2, and equal to 0. So from that we will get VA 27.68 kN. And then the next one is total Fx equals to 0, total FF equals to 0 also. So VA plus VB is 549.36 kN. So we substitute the value of VA into the equation, so we will get VB to 74.68 kN. Next, we have to calculate the centroid. Why we need to calculate the centroid is because it will establish a center of gravity of our structure. So here I have drawn my structure on the axis, y-axis and x-axis. So the calculation will be, we only have one part, and the area is 9.15 meter squared. The x is 7.5, y is 0.31, ax is 68.63 meter squared, while ay is 2.84 meter squared. And here we can conclude that from the calculation, x is equals to 7.5 and y equals to 0.31. So this is the value of our centroid, and it is located in the middle of the structure. Next, we need to calculate the moment of inertia. Here we have two axes, which is x-axis and y-axis. So for the x-axis, we have to make a table. Also for the y-axis, make a table. And we have on the x-axis, the area is 9.15 meter squared. The ix is 0.28, the d is 0, and ad is 0. So the calculations will be summation of ixx is 0.28. While y-axis, we have the same number of area like x-axis, which is 9.15 meter squared. Iy is 171.56. The s is 0. As squared is 0 also. So the calculations will be summation of Iyy is 171.56. So this is the moment of inertia for both x-axis and y-axis. So that is all for the calculation for short span bridge. Thank you.
Not least, this is the final structure that our group decide to do in this continuous assessment for static and dynamic, which is gate structure. So this photo was taken from a college camera, and this is a free body diagram that was sketched using Samsung knots. And we can see here with the length of 24 meter and the height of 10 meter with 200 kN are downward forces acting on the gate structure. So introduction is a moving frame or fixed structure that swings, slides, and rolls. Control entry and exit through fences, walls, or opening vegetation. Open the gates made from wood, forged material, etc. in iron, extra metal, or other material. Door front surface when in enclosed position, a view through a gate, a position perpendicular to the gate. Fixed is completely solid, opaque material or material such as wood, wrought iron, and extrude metal 20% or more material on the face surface view through the gate when the gate is in closed position and place it in perpendicular to the gate. Example, the gate structure in this college were taken in front of College Powira on 11 December 2022. Location, Gate College Powira. In support reaction of the gate, on horizontal axis, AX and BX equals to 0, which there is no forces and acting on the horizontal axis. Meanwhile, for the moment is force time distance, and we can deduce BY value is 100 kN. So for the AY value, we can get 140 kN. Moving on, calculation on centroid. Right now, since the gate in a rectangular area is section 1 to 24 times 10 is 240 meters square. For the x value is 24 divided by 2 to get the midpoint or the center of the gate, which is 2. For the y value is 10 divided by 2 is 5, and ax equals to 260 times 12 is 3120, and divided by 240 you can get 12. For ay value is 260 times 5 is 1300, when divided with 240 is 5.4167, and this is the moment of inertia of the gate. So right now this is the first section, which is section 1, 24 times 10 is 240. For Ix value is referring to inertia, so we are using BH3 divided by 12. 24 times 10 power 3 divided by 12 is 2000, and there is no change in terms of dy value. ADY is 240 times 0 is 0. For part section 1 also having the same amount, 240 meters square. For the inertia value is also getting the same, 2000, and dx value is 0, and ADX square is 240 times 0 square is 0. So last but not least, for part x and y is referring to x-axis and y-axis, both have exhibit inertia 2000 meter forward, and same as well as y, 2000 meter forward. In conclusion, engineering programs can be benefit from the utilization of static dynamics textbooks. They were created for theoretical engineering degree. Numerous programs use this book, although they employ different levels of mathematical sophistication. However, in line in goals of civil engineering education, emphasis should be in place in application of analysis to equipment and structure rather than mathematical breakthrough. And that's all for our group presentation. Thank you for listening.